Hey, level physicists, what's the crack? So today we're going to do is some simple harmonic motion. So what we're given here is that we're given the time period of oscillation of my pencil in water and given the length of the pencil. I want to calculate its acceleration, okay? So I probably just draw a little diagram. I've got my pencil and it's water. I know its length. And what's happening is, let's say we're going to displace the pencil by -5 millimeters, okay? So what that means is I'm going to take the pencil and move it down, because for me, downwards is always going to be negative. I'm going to move the pencil down by 5 millimeters. So I'm trying to figure out then what will its acceleration be, trying to push it back up. Because we know for simple harmonic motion, the acceleration is always proportional to -x, negative the displacement. So when I look at my data sheet, I can see the acceleration equals -w squared times x. So what I already have is my x, so I know the acceleration is -w squared times by -5 times 10 to the -3, because it's millimeters. So now I just have to remember how do I find w, okay? So on my data sheet, w is 2 pi f, and then I remember from GCSEs that frequency is equal to 1 over the time period. So I know that w is actually equal to 2 pi over t. So now I just have to figure out what is t. And they told me to use this math up here, okay? So to find t, what I'm going to do is 2 pi square root of L, which was 85 millimeters, or 85 times 10 to the -3, divided by G, which is 9.81 on Earth. Okay, so that's my t. Okay, so now I'm just going to fill in my values. So what I have is A equals minus W squared. So I need to take my brackets and square everything inside it. So what's inside it is 2 pi divided by t. So what I have is 2 pi divided by this number. So divided by 2 pi times the square root of 85 times 10 to the -3 all over 9.81. And then that whole thing is squared. And multiply that by -5 times 10 to the -3. Okay, so when I plug this math in my calculator, my final answer for acceleration, because I have two negatives, which multiply each other to give me a positive, so my final answer for acceleration is going to be 0.577 meters per second squared. And that makes sense as a positive number because the acceleration will be trying to pull it back up to its equilibrium position. Remember we said in my diagrams, down is negative and the upward will be positive. Okay, so that's grand.